Time only moves forward, but why? In this episode, what black holes revealed about the nature of time itself, how entropy creates the arrow of time, and why the laws of physics don't care about past or future. Welcome to CurioScope, where curiosity meets science. Let's dive in. Time always moves forward. We are born, we grow, we age. But why do we never see the reverse? Why don't shattered glasses reassemble themselves? Why doesn't smoke return to a match? What makes time's arrow point only in one direction?
Here's something fascinating. The fundamental laws of physics don't really distinguish between past and future. Newton's equations of motion work the same forward and backward in time. Even in quantum mechanics, if you recorded the motion of electrons and then reversed the film, it would still obey the same rules. Einstein's theory of relativity also treats time as just another dimension, without a built-in preference for direction. Physics seems to say, forward or backward, I don't care. So, if the laws are symmetric, why does the universe itself make such a clear distinction between past and future?
This is where the second law of thermodynamics comes in. It states that entropy, a measure of disorder, always increases. Think about it. Ice melts into water, but water never spontaneously freezes without help. A glass shatters easily, but it never reassembles itself. The reason is probability. There are far more ways for matter to be disordered than ordered. And that imbalance gives us the arrow of time. We move from lower entropy to higher entropy, from order to disorder. Our own perception of time is tied to entropy as well. We remember the past because it left physical traces, changes in our brains, in photos, in records. The future hasn't happened yet, so it leaves no marks. That's why we can recall yesterday, but not tomorrow. Our sense of flowing time is a reflection of growing entropy all around us. But in some places in the universe, time behaves in astonishing ways. Black holes. Their gravity is so intense that it warps space itself and slows down time. To an outside observer, anything falling into a black hole appears to freeze at the event horizon, never crossing it, as if time itself has stopped. Yet for the falling object, time flows normally, while the entire outside universe appears to speed up. Black holes reveal that time is flexible, shaped by gravity and space. But even here, it never runs backward, only forward. Could time really flow backward? In theory, the equations don't forbid it. But in practice, the chances of entropy spontaneously decreasing are so astronomically small that we never see it happen. That's why broken glasses don't fix themselves and melted ice doesn't refreeze on its own. The universe always favors disorder, and that gives time its one-way direction. The laws of physics are symmetric. They don't care about past or future, but entropy turns that symmetry into reality, giving us a universe where time flows only forward. Even in the most extreme places, like black holes, time bends and stretches, but it never reverses. The arrow of time always points ahead. This is CurioScope, science made simple. Subscribe and join us as we uncover more mysteries of our universe.